Hi, we're live. I'm streaming. Cat, at least say hello. You're internet famous now. You're gonna be immortalized on YouTube. Weird geeks search it to learn how to make Game Boy games. They're gonna see you. They're gonna be like, yeah, making Game Boy games. It's a good life choice because people who make life choices like that end up with adorable cats like you, who are the best. Oh my gosh. No stream today, folks, or no programming today. It's just going to be me petting my cat for 90 minutes. 90 minutes of cat petting. Heck yeah. No, I should focus and give my audience the content it craves, streaming content it craves. Yeah, look at you, Nelly. What is the streaming content that my audience craves? This is not a cat. It is making a Game Boy game. Let's boot our game up. Let's look at the progress we have made. We got our title screen. It comes in. It looks awesome. We start the game. Game looks okay. I mean, it plays fine. Game, whatever. Good title screen, good cat. Game over screen looks, doesn't need to look all that great. I do like a game with a cool game over screen, a bunch of like crazy English or something being like, the mission has been fail. I'm drinking the last of a glass of almond milk. Don't mind me. It's gonna be a weird loosey-goosey stream today, I guess. All messed up on almond milk. Right. What I wanted to do today was add support for multiple levels. Right now, we only have one kind of level, and I want to be able to have different kinds of levels. Nelly, are you leaving? Are you leaving me? Have you had enough pets? Ooh. Oh, be careful, Nelly. Watch your footing. My lap is unstable ground. So that's what we're going to do today. We're going to work on getting multiple levels. So how are we going to do that? How are we going to do that? Basically, it's not going to be too tough. What it is just everywhere where we've got this like fixed access to the stage data, we need to sort of add some indirection. Bye, Nelly. I'll miss you. Okay. Yeah, let's get cracking. All right. So let's go look at the. Just go sort of trace the code from the beginning to figure out how the stage is loaded in the first place. All this stuff doesn't have to change. Turn off screen, start title screen. None of this stuff changes. It's over in the title screen. What happens when you end the title screen? Start game gets called. So I think this is where we're going to have to start making changes. Either in a knit game or in draw stage. Let's go look at a knit game first. What is the key? The key stroke. There we go. A knit ball, a knit stage. Yeah, this is where things are going to get weird. So what I'm going to do is instead of I'm going to have a variable which I'm going to call current stage. And so what you're going to do is you're going to say which stage you want to load. You're going to put that to current stage, and that's what it's going to use. So and then, Nellie, what's the matter? Honestly. So let me just look. Init total bricks uses the data that's currently loaded. So we don't even need to touch that. We just need to look in init stage map. See, right now, it just immediately pulls from stage data, which is this. We're not going to have stage data anymore. We're going to have stage 1 data. Or even, so I was going to say we could have a pointer table, but we don't even necessarily need to do that because every stage, at least unless I introduce some kind of compression, which might be a thing in the future, but for now, not necessary. Stage 1. Stage 2. Or maybe I'll even call this stage 0 and stage 1. Like for now, it's just each stage is exactly what did I say? 16 by 1, 2, 3, 4, 5, 6, 7, 8. 16 by 8. So each stage is exactly 128 bytes. So that means all that you need to do to load the stage is figure out where your stage data starts, is take the current stage and multiply it by 128. So how do we do that most easily? And then the other problem, of course, is that that's a 16-bit thing, and we want to base it from like wherever the stage data starts. So I'm actually wondering if it might be a good idea to just use a table, just because that makes things easier, and it means that one-day compression will be super easy. And compressing the stage data might be a good idea, because if I have 120 bytes of stage, well, maybe that's not necessary. Like even if I had 100 stages, that's like 1 kilobyte of stage data. Maybe not necessary. Maybe, okay, yeah, that's fine. What's the syntax for this again? Yeah, it's a line 8. Let's do that. So I'm just gonna have, I don't know what I want my second stage to look like. Like, I'll just make it look similar but different, so that way, you know, it's nice and easy to distinguish the two. I'm gonna worry about like actual level design later. So, and multiplying by 128 is going to be like basically 7 bits to the left. Nellie, what is the matter? She always gets like this whenever she's using the litter. I'm a little worried. I think I might need to take her to the vet. Maybe she's having some sort of digestive trouble and using the litter isn't comfortable for her. Or it's also possible that she's just one of those cats that gets crazy when she uses the litter. Oh. And it's also possible that because she's a Siamese, she's just very loud. It's just that her meows sound so angry. Like, just like really like. Anyways. So we're going to take the current stage and we're going to multiply it by 128. So what that means, if we imagine that the current stage is some number, let's say we're loading stage 33. I'm going to open up my calculator. So let's say we're loading stage decimal 33. Well, in binary, that looks like that. This is a word. So in binary, that looks like that. So, and let me just actually copy that so we can see it, you know. If we want to multiply it by 128, the result looks like this. So I'm going to line these up so it's like easy, nice and easy to see. So what has happened here is we've shifted this to the left by 7 bits. So this bottom bit ends up 7 spaces over there, just at the very top of the lower bit. And yes, yes. And then these 7 bits get placed, you know, they when I show you, will line up perfectly. Oh my God. How am I supposed to focus on my stream when I've got you screaming? My God. Where was I? I have no idea where I was. I'm not going to bother explaining this. We want to shift left by 128, or by 7 bits, which normally would be kind of slow. But there's nice, easy ways to do it, and I'm going to do it. Basically, we want to put this into HL. The L, the low byte of it, is just going to be whether the low byte of HL is the top bit of it is just going to be whether the low bit here is set, and then the rest gets moved into the H, and then we just need to add the high byte of stage data because this is 8-bit aligned. We don't need to worry about anything else. Please feel free to like leave a comment or something if you don't understand on YouTube. I will answer it for you. I just feel like I'm gonna go nuts if I don't start coding because trying to explain with my cat screaming intermittently is driving me up the wall. So let's get the current stage. What's the nicest way to do this? I'm just gonna write turn off everything except for the lowest bit, and then rotate it. I believe RRA is what let me double check this actually, because I can never get all the rotate instructions in my head. So I believe I want RA. There's usually a good diagram. The carry is copied into bit 7. No, that's not what I want. I want RCA. The bit leaving on the right is copied into the carry and into bit 7. That's what I want. I want RRCA. And then I'm going to put that into L. And L is done now. That is going to be the correct value for L. And what I might do, actually what I might do just to make this for now I don't need to, the only place I ever use the current stage is to load the map, but in case I ever want it for other things, I'm going to do this in here, and then that's going to make anything else that needs to use the current stage, it can just load the pointer and doesn't need to do any of this sort of this trickery. So then I'm going to get the current stage. Oh my God, Nelly! This number, and all we need to do is shift it to the right. So let's take this example here. This was the current stage. Well, we now have L is going to equal just that. And then H is going to equal, we start with this, we do the shift right. We're going to get 0, 0, 0, 1, 0, 0, 0, 0. This, which is what we wanted. So all we have to do is a shift to the right, and then because this stage data doesn't start at 0, 0, it starts at some page break. I want to make sure this is correct. I just need to, I believe this is correct, but it must be correct. And then I want to add stage data, and then I'm going to load that into H. And there, that is the that gets this current stage pointer into HL. And what I will actually do is that I will load HL with current stage pointer, and instead of writing it into L and H, I'll just do it like this. I believe that's correct. I just want to make sure that this part of my reasoning, must be correct, because, oh, I do need to add pi. I believe that's right, because it's just going to be like, for example, like 43, I don't even think that's in ROM, 43 plus current stage shifted left by 7, and that'll always be either 80 or 0, and then, yeah, okay. I feel decent about that. I feel pretty decent about that. So we're going to do that. So then all we have to do to init stage map is what I called it, is instead of loading HL directly, we're going to load current stage pointer, and what is my opinion on rigorous proofs for correctness for problems involving floating point numbers? Oh my gosh. I have opinions on this. It's not super relevant to what I'm talking about, but I'm happy to chime in. It's absolutely possible. It's an enormous pain, but like floating point numbers, there's nothing magical about them. There is a great article on the internet called something like "What Every Programmer Needs to Know About Floating Point Numbers." That's definitely worth a read. That would be my immediate suggestion. Or should know, not about memory. I'll just put the link up in chat. Yeah, here we go. I would strongly recommend reading that. Let me put that up there. Yes, that is, I guess that's who it's by. Yes, that would be the most basic reference. If you want to learn how to carry out floating point operations with the least possible error that is somewhat outside of my wheelhouse. I know that they're I never took a class on this in college, is what I'm gonna say. I know that there are people who do this sort of thing, but I'm not the person to talk to about like really precisely and very safely computing floating point, doing floating point calculations. Unfortunately, even the right term for what you even call that is escaping me. So for really hardcore like mathematical floating point stuff, not I don't know. I could sit here and Google it for you, but it's just honestly never really come up. I've never done anything of that sort. Like when doing game programming, that's almost never what you want to do. In game programming, like you always want to do stuff that is fast and inexact. that is like obviously this is a whole different degree of sophistication from what you're talking about, but like even in my little Game Boy game, the collision detection I do just by using the center of the ball. Like instead of doing a whole bounding box, instead of like doing proper, and I only do it on a full frame step. Like the ball moves 3 pixels a frame. I do the collision detection after it moves 3 pixels. I don't do any sort of like integration or anything like that. So this sort of stuff kind of outside of my wheelhouse. So sorry. Yeah, sorry. Error. Well, doesn't error accumulate? If you're doing anything, if you're doing real math, error accumulates over time. I'm not even using floating point. I'm using fixed point math. And there's no actual multiplication going on or anything like that. So in this case, no, there's no real error to speak of. If you're doing real math, error accumulates over time. Yeah, that's just not a problem here. The Game Boy doesn't have any kind of hardware floating point. Software floating point would be impossibly slow on it. Like you just got to use hacks when you're doing this sort of thing. So yeah, here we go, loading the stage maps. So the only change I wanted to make here was instead of using the fixed content for this or constant for the stage data, we're going to use the current stage pointer that we've initialized. And I got to make sure to call that as well. Stage pointer. So load LA. Easy as pie. So I believe that this should work so long as I remember before calling init stage, which I believe I only ever call in the game code. Load current stage A. As long as I do that, this should just work. So let's reload the ROM and see how it goes. Yeah, that worked just fine. Now, what happens if I load stage 1 instead? I'll reload ROM, run. If I load stage 1 instead, yes, I get my second stage. Awesome. I have support for multiple stages now. So I'm going to save those changes. Oh, whoops. I do want to still start on stage 0, so just make sure I have that change correct. Support multiple stages. For now, this should do it. So then the next thing I want to do, this is like pretty minor, but because I mean, I shouldn't say it's minor, but like right now, it's right now it doesn't matter because it's impossible to win. But if you can win, if you can beat the stage, yeah, here instead of jumping to game over, I want to jump to something called level complete. Which is going to work in, much the same way for now. I don't even need to do all that. Oh my god. Let's go to a init game. It's going to. I'm going to split a init game up into new game and a init game. So new game is going to be the stuff that we only call right when the game starts. Gosh. Actually, maybe even let's see. Starting lives, number of lives. Maybe even put this into like, well, whatever. Put that there. Init game. So then where is it that I call it init game from? Start game. Right. So new game. So then the only other thing I need to do is, this is a little confusing, but it's not the end of the world. just when you beat a level, we're going to turn off the screen. We're going to call init game. Yeah? Why are you being so squawky today? We're going to, all we have to do is draw the stage, and then turn the screen back on, and we should be good to go, I think. I think it should just work. I mean, I guess we'll see. Maybe I should make this stage really, really easy, is what I should do. Or at the very least, less hard. So let me, I built that, right? Oh, and that's the other thing, level complete. Before I do that, current stage. Of course, I'm going to need one other thing here, which is I'm going to need to be able to detect the final stage and jump to an ending of some kind. But let's just make sure that this works first. Which is a big if reload ROM run. Let's see how it goes. Oof, well, I want to get rid of that giant column on the right. Did not think that through. Did not notice that. Rebuild. Hit escape. Reload the ROM. Hit run. This is at least. Probably. Oh, even this is too hard for me. My God. It's because the ball speeds up so quickly. I really gotta adjust that. Okay, let me just turn this into. Just for debugging purposes, might as well make this stage extremely simple. Run. My God. The other thing I need to start doing, if I'm like serious about making this a full game, is like sort of spend some time thinking about like what is it that makes a breakout game fun? And how do I lean into that? And that is hard because right now I just don't feel like this breakout game is very much fun. Oof. My physics just don't feel quite right yet. You know, just gotta do some adjustments. No, over here. Come on, you can do it. Oh my gosh. I should add a cheat code to just automatically beat the level so I can test this. I do want to just make sure that this actually works. There we go, one brick left. No! There we go, and there, it worked. Loaded the next level. That's what I was going for. Heck yes. I wanted to find that HL in here. So what I'm going to do, instead of HL, is I'll A, we're going to compare it to num of stages. Let me do this with the screen on. In fact, back. All right, there we go. And then here, I'm just going to add this, not here. I just got to add a constant, which is like num of stages. And that's equal to 2 right now. And we just need to update that every time we, every time I add a stage. So, we now have multiple levels. Multiple levels. Heck yeah. So anything else I wanted to do, because I've been streaming for just over 40 minutes, which is not terribly long, but also not terribly short. One thing I want to do, and maybe I can do this, is I want to make the ball a little bit smaller now that I've got these 8x4. Now that I've got these 8x4 bricks. So let's do that. Probably want to make it smaller still, but let's start with this. Start just by shrinking it by 1 pixel. I'm going to go from there. And then the other thing I do need to do is I'm going to need to adjust the ball's size. So now it's 7 or 6 by 6. Let's see how that looks and feels. I mean, it looks and feels fine, and an awful lot better. And one thing I noticed is that I'm going to just chop off that, I think. The ball looks really nice and around here, and then as it moves around, it starts looking a little weirdly diamond-like, which I don't like. So I wonder if I just chop off the softest bits on the side, it'll look a little bit better. So that's going to bring it down to 4 by 4. It's also, this isn't right. It's a little embedded, which I need to fix. But let's go back to that sprite. 0, 0, 0, 0, 0, and 0. Let me see how that looks. Sorry, file, reload ROM, run. Okay, I'm going to need to adjust the ball's positioning, but when it's in motion, it looks great. That looks perfect, really. I just need to adjust the ball's position on the paddle, which does not look so good. So that's in ball. I believe there's a procedure called like place ball on paddle. Put ball onto paddle. I'm honestly surprised that this doesn't just work. X or A. Right. Take the paddle's position and then subtract the ball's height. Why doesn't that just work? Oh, because the sprite needs to be adjusted by, there needs to be an adjustment for the size of the sprite. Like we don't. Oh, I'm actually really, I'm surprised. Why doesn't this work? Let me go look at VRAM so I can get a better understanding of this. The ball is at 7C, and the paddle is at 80. So C, D, E, F. Right, that makes sense. And what is obscured? Like this, it should be. Oh, right, because so what's happening is the top left of the paddle sprite is up here. And then it's moving over here, so we're only getting, so we just always want to subtract, we don't always want to subtract 8. We want to always subtract hell. In this case, we want to subtract 6, right? Because we want to move up the meat of the paddle plus the, oh God, I don't know, man. God, I'm just like fried today. This should be pretty straightforward. If we subtract up 8, we're going to end up with there being a space of, you know, however many pixels is at the bottom. We want to subtract 8 minus the difference between the gap between the bottom of the ball and the bottom of the sprite. So we want to subtract 8 minus, I think. I feel like this is probably right. So what would we? No, because then we'd just be subtracting 4 with the ball. Is it like what is it? This is like the most boring, silly thing. I don't know why I'm making my audience sit through this tedious thought process. So if the ball starts at the bottom, we want to subtract 8. If we've then cut off, if the ball is at 6, if the ball is 6 pixels wide, there is a gap of 1 pixel between the bottoms. So we want to subtract 7. Ball height, if it's if it's 5, we want to subtract 6, right? So something like this, like this is going to work. We're going to get, right now the ball height is 4, so it's 8 minus 4, so we want to subtract 6. Let's try that. I think that's right. Like who cares? I should just hard code it and give up. But here we go. Yeah, I mean, that looks right. That feels right. That would work completely fine for the two ball sizes that I have given any thought to. That doesn't feel right, though. That just seems to have gone through the paddle. Did I properly adjust the ball height and the ball width? I did. Let me see if I noticed that again, or maybe that was just an illusion. I mean, it seems to play okay. I feel okay about this. It might have just been an optical illusion of me seeing things or something. No, that didn't look great. When the ball's moving really quickly. Right, when the ball's moving at top speed right now, the ball can actually burst right through the paddle, I believe, which is not good. Because the ball center could be up here, and then the next frame it could be like over there. Maybe if I just increase the paddle height a little. What do I even use this for? Where do I use the paddle height? Under collide. Oh, to see if, right, if the ball goes down here, I'm gonna just, this is a hack, but I'm gonna increase the paddle height a little bit. It's like not gonna be a problem, I don't think, and it's gonna help the ball bounce. It's going to help make sure that like the ball never goes through the paddle. And the ball still seems to go through the paddle there. Oh, and that's the other thing, right? When I do my collision detection, I think when I do the collision detection against the paddle, I think I do try to use the ball. Let me go look in collide. I try to use the ball's bottom. So let me adjust that actually. Check bottom, not bottom collide, that's fine. Right, and actually I bet, yeah, when I'm doing it against the sides, I need to adjust this a little bit. Because right now I actually want -16, oh god, it's just going to be the same thing again, like 8 minus ball height over 2. So in this case it is, yeah. And same with the left, it's -8 minus ball width over 2. And here we want it to actually be allowed plus 8 minus ball width over 2. And same with the top. That doesn't matter too, I don't know. Do I even notice this? I probably don't even notice this. That's not a problem. But then here for the paddle collide, I also need to adjust this to, you know, note the well, we're using the, actually this is interesting. There's no reason for me to use the center for the paddle collide let me use the bottom of the ball. The bottom of the ball is going to be at the sprite position plus 8 minus ball height over 2. Let me do that. And let me make I'm going to make the paddle extra big like I suggested earlier to help make sure that this works. Okay. Where is that? That's going to be in paddle.asm. Let's going to make this 8. And then the other thing is here in collide, like if you do collide, new Y position is just above the paddle. This is wrong. This should be paddle Y minus ball height. Actually, this is ball height plus 8 minus ball height over 2. I believe that's all right. Just like some minor tweaks, but I think that's right. Oh, whoa, whoa, that's not good. Really not good. So yeah, in this case, the paddle should be, oh. Yeah, let's just do that. That'll do it. That was the problem. I was believe that'll fix it. That feels a lot better. And I don't think there's any, I don't think at this point there's any way, even at top speed, for the ball to go shooting through the paddle. Yeah, I think that looks and feels an awful lot better. Cool. I think that's good for today. Sorry, it was a little, I wouldn't say off my ball, but I need to get better sleep is what I need. But I don't think I did a great job of explaining a lot of what I was doing today because I was kind of muddling through it myself and because my cat was just constantly distracting me. But nevertheless, we got some good changes here today. We got multiple levels in, we got a smaller ball, we got improved collision detection, just probably a better feeling game, better looking game for sure. Better. That ball actually looks like a ball and not like a diamond. So I'm pleased with this. Cool. Thank you very much for watching. Tomorrow, before I say thank you for watching, I'm out. Tomorrow, what are we going to do? And let me save that change too. Tomorrow, I'm going to look to start integrating a sound engine into the game so that we can get some sounds going. That's what we're going to do. And hopefully that should be straightforward. I'm just going to be taking someone else's code. I've never, there is an open source, widely available sound engine that I'm going to use. So I've never used it before. Hopefully it'll be easy. Anyways, thank you very much for watching. Have a great rest of your day. I am out.